Hi, this is PICO System 3 from Erica Synths. Like the previous PICO systems, the idea here is to bundle a lot of narrow modules together into a single standalone system. However, compared to PICO System 2, a few features have been removed or swapped out for others to reach a lower price point. That said, quite an interesting feature has been added, and that is Buchla easel style preset card support. If you're interested, I'll put this entire jam at the end of the video. Let's get started. Let's start with an overview. PICO System 3 is much less expensive than previous PICO systems. It's 450 euros for the desktop version and 400 euros for the Eurorack module, compared to around 1,000 euros for the previous System 2. So what accounts for the cost savings? A few things. The previous PICO systems had independent modules that you could swipe out individually. Here, all the modules sit on one board, and one board costs less to make than 13 or 14 individual modules. The disadvantage, of course, is that you can't swap out individual modules here. It's all or nothing. Beyond that, many digital modules like a digital sequencer, sample playback, and digital effects have all been replaced with simpler all-analog modules. One thing has been added though, and that is support for analog preset cards. PICO System 3 comes with 5 bundled preset cards and 5 more empty ones that you can use to create your own presets. I'll talk about how you make them, as well as this DIY one in a bit. Left to right, you have a 2 to 4 step continuous voltage sequencer, meaning that it generates unquantized raw voltages, 2 oscillators, a VCA with internal FM links to the oscillators, and a DC coupled mixer, a mod or LFO module with a few different waveforms, a noise generator and random pulse, 2 ASR, attack sustain release envelopes with looping options, 2 low-pass gate modules. These have 2 modes, either an AC coupled VCA or a resonant low-pass filter mode, then an analog bucket brigade delay that goes up to about 1/3 of a second, and finally 2 more mixer modules. To complete the overview, as I mentioned earlier, PICO System 3 also comes in a Eurorack version. This is the desktop version, and it comes with a few extra cables, a power supply, and the case has another mono output in the back. It's also important to note that the desktop case is solid metal, meaning you cannot take the module out of the standalone case and mount it as part of a Eurorack system. Okay, let's talk about the preset card slot and these cards. There are 2 types of cards, either factory presets that have pre-existing wired connections or empty cards that you can make yourself. So how does this work? Well, if you look at the holes on the card, you'll notice that they're laid out exactly like the jacks on the front panel, with a few exceptions, probably because they didn't have enough connections on the card. To make a connection on an empty card, you need to solder one of the outputs to one or more of the inputs. The idea is that if you have a complex patch that you find yourself making many times, you can just make those connections on a preset card and clear up the panel for other ideas. You can always override connections in the preset card, so these cards should only be seen as a starting point, not as something that limits you to a particular arrangement. As I mentioned, PICO System 3 comes with 5 factory presets, and the manual comes with overlay cards that both show you which connections these presets make, as well as what the recommended knob positions are. And they have these holes in them, so you can place them on the panel and both see what's going on, as well as configure the knobs that are important to figure for a particular preset. Which is, I guess, a good a time as any to say that the preset cards save patches but don't save knob positions. Now, as I was exploring these, I noticed one little hole that doesn't exist on the panel, and that's a ground connection. Now, my guess is that Erica Synths figured out that people might want a little more than just to make simple connections, which is exactly what I did here. In the case of SLOOPOP, which is an appropriately named slew limiter for the sequencer, I built this with my synth buddy Isaac, which you may have seen in a previous episode. And what this does is add a simple slew limiter between the output of the sequencer and the input of VC1. All it took was a simple resistor, potentiometer, capacitor, and of course a blue knob. And the idea here is this. So let's take, for example, this simple sequence, right? I've got these steps sequenced in the sequencer, and they're jumping from voltage level to voltage level, controlling VCO1. right? If I plug in this card in here, nothing happens because the card gets overridden by this connection. But if I take this out, right, then the card makes that connection built in the card itself, and by turning this knob, I can add a little slew between the steps, right? Now, obviously, I can take this to an extreme if I wanted. So that's how I added a little bit of controllable slew limiting to the sequencer. Now, what would have been even cooler was if they would have added plus and minus voltage connections here. So your options are somewhat limited to passive components unless you want to get really creative and add a battery here or borrow 5 volts, say, from the sequencer. So expansion options currently are limited to passive components unless you want to add power to the card itself. Another idea for these patch cards, if you just ignore all the resistors and knob and stuff, is to add these slots, right? Solder these slots onto each of the jacks, and then you could create patches with little patch cables without any soldering. This would let you create sort of mini-me version of patches on these cards, which you could just plug in and take out and then modify if you wanted without any soldering. Okay, let's dive in and look at the different modules very briefly. As I mentioned before, the sequencer has between 2 to 4 steps, which you choose with this switch, right? 2, 3, and 4 steps. It sends out raw voltages out of this output and can be clocked through this input. If you wanted, you could use it as a simple wave shaper. So I'm controlling oscillator 1, which is clocking the sequencer, right? And it's at 2 steps now, so I could change the height of the different pulse steps. But if I move it to 3 or 4 steps, right, I have slightly more control over the wave shape. I could play this. And of course, imagine this with a slew limiter. Let's move on to the oscillators. Both have a simple triangle output with octave control, and then a more complex wave shape for VCO1. It's a pulse wave with a variable pulse width, right? And oscillator 2, which I'm controlling with a keyboard here, right, has octave control as well. Both have manual control, right? And then the shape version moves from a triangle to a square to a variable pulse shape like this, right? So that's the wave shaper on oscillator 2. You've got shape CV control for oscillator 2, pulse width control for oscillator 1, and then both have FM options, exponential FM for oscillator 1 and linear FM for oscillator 2. And the idea is that you use one to modulate the other. So for example, I will modulate oscillator 2 using the linear FM input. So let's hear what this sounds on, say, a triangle wave shape. You've got linear FM amount, right, from slow rates to higher rates. And I could push the oscillator into even higher rates, let's say with a sequencer in this case. Right. So linear FM. You need to get the ratios right for this to play well. The VCO control module also has a regular VCA, so if you don't want to use it for linear FM, this is the VCA CV input. You've got an audio input or voltage level input and an output through here, and you also have offset control with this knob. To the right of the oscillator section is the first of 3 mixers. This one has 3 inputs and the other 2 have 3 and 2 inputs each. Now, why, would you ask, would a synth with 2 oscillators need 3 mixers with 8 inputs in total? Even if you count the noise generator and 2 filters, that's 5 sources. You've still got 3 extra slots. Well, you could of course use these extra inputs to add in external audio and mix it in, but all 3 mixers are DC coupled, which means that you can use the level controls to attenuate voltage signals coming into them. This comes in very handy because many of the parameters don't have a trimmer associated with them, neither the envelopes or the LFO going out, so it's always extreme voltage changes, nor many of the parameters such as the filter cutoffs or bucket brigade delay, time, attack delay, CVs coming in. None of these have trimmers. So you could use any of these mixers as an attenuator, and the cool thing about having multiple sources is that you can combine two modulation sources into one. One thing that is missing here and would have been nice is an attenuverter on maybe one of the mixers so that you can invert the polarity of the modulation, say for example of one of the envelopes. Okay, let's move on to the mod module or the LFO module. It has a few timed outputs which can be clocked using this input or just changed using this rate knob. A slightly annoying but very useful way to demo an LFO is to change the pitch of an oscillator. So let's do that. I'll patch the sine output, say, into the exponential input of oscillator 1, which does have a trimmer. Right? So this is the sine wave. It goes up to about 20 hertz, I think, but can be pushed with voltage, by the way. Then you've got a pulse output, right? Goes up and down. You could get to nice intervals here with the exponential FM, by the way. I'll skip random pulse for a second. There's sample and hold, which is just random levels. Right? And then noise has nothing to do with the LFO. That's just a noise output. Right? Seems sort of like whitish noise. Notice a dip around 7.5 kilohertz. Don't know why that. Maybe that's just my module. Right? The noise generator. And then the random pulse is an interesting output. This sends out a trigger in time with the LFO, right? So sort of like a clock, but not on every pulse, not on every cycle. So you get a random event every now and then. Next up are two identical envelope generators. These are ASR, or attack sustain release envelopes, meaning that the attack stage happens when they get a gate, and then it's held until the gate ends, whereby the release or decay stage starts. They'll function as attack decay envelopes if you send them a brief trigger, but they'll always hold on a gate. So if I press a key on the keyboard, right, it'll hold, and then I can add release if I want. Or attack. Let's shorten the release. Right. Attack. And decay. Right, but there's always the sustain stage in between. There's a little button here so you can trigger and hold the envelopes if you like, and they will loop. And in this case, the sustain stage is obviously eliminated. This also gets pretty short, but not too short. I think about 30 hertz here. And both envelope generators have attack CV and decay CV controls. It would have been nice, by the way, if one of the envelopes had an attack decay mode rather than an attack sustain release mode, so that the envelopes could treat gates like triggers. Sometimes you just want a quick filter decay on top of a longer VCA envelope, and it's a bit of a challenge to make that happen here, because if your clock or sequence tends to send out gate, then the decay stage only happens at the end of the gate. Let's move on. You've got two low-pass gate modules. Low-pass gates means that they can work either in a VCA mode, which opens and closes with changes in the harmonics. It's very subtle, but you might be able to hear it. That's in VCA mode. And then in VCF mode, they're a filter. Seems like it always has a little bit of resonance, and resonance here definitely can be vocal. Will self-oscillate and get pretty loud and even yell the harmonics beyond 12 o'clock. Right. So let's maybe take a listen to the filter without an envelope. Right. This is without any resonance. And if I add a bit, even more. definitely an aggressive style filter. And I'll lower level if we go all the way up high. And it will self-oscillate. Even if I take out the audio source, right? So that's the filter. It doesn't track volt per octave, by the way. You can, with a VCA, sort of get it to play across one octave, but it doesn't track consistently across multiple octaves. Let's move on and take a look at the bucket brigade delay, the analog delay circuit. Right? It's got dry-wet control, as well as an internal filter. Right? This is with the fewest harmonics filtered in the delay, and you can progressively filter more of it. You've got time and feedback settings as you'd expect, right? All the way from very short, which will oscillate, by the way. Right, so let's say if I disconnect the source, it will still self-oscillate as you would expect. There is this high-pitched sound above, say, 3 o'clock with a delay, right? Which you can filter out either with this, still there a little bit, or just pass it through one of the filters. There's 2 of them if this bothers you. And let's get this going again. Right? So simple feedback and time control. Dry wet, as you would expect. There's also time CV, so you could modulate this if you wanted. Right? So that's the bucket brigade delay. Then, as I mentioned before, there are 2 additional mixers. The output of these mixers is normaled to the main output, and you also have a headphone output over here. But if you plug a cable into either of the outputs, they'll be disconnected from being routed to the main output, and you can just use either this mixer or mixer 3 as an attenuator or DC coupled mixer. Okay, so let's talk about pros and cons. On the cons side, since this is a modular system, missing features can be added with external modules, so what I think is missing may be different than your opinion, which of course you can and should state in the comments section below. I mentioned this before, what immediately jumped to me as missing was not the fact that the sequencer had only 4 steps, it is what it is within the space, but it would have been nice to have a quantizer here so you could easily play note sequences without having to use your ear or a tuner. That said, if you're into melodies, you're probably better off getting an external sequencer or a keyboard like this, which sends out CV and gate and has a pretty nice and long sequencer built in. Another module or feature I think is missing is an inverter. It would have been nice to have one of them on one of the mixers. I thought of making a patch card with an attenuverter, but if I'm not mistaken, you need some sort of negative voltage source for that, which wasn't available here to my knowledge. Just to recap things I mentioned before, filters don't track volt per octave. Didn't bother me, but it may be important to you. And as I mentioned, if you get the desktop version, you cannot take the module out of its case, unlike a few other semi-modular desktop units that have that feature. So if you're thinking of potentially rack mounting this, you might want to get the Eurorack version with a third-party case like the pods from 4MS. Finally, the placement of the jacks below the knobs might make sense in a Eurorack case where this module sits on the top row, but if you're using regular cables that stick out, they make the knobs pretty hard to get at. That problem is easy to solve using 90-degree cables like tendrils, which I use here. On the pros side, this is a rather capable synth. They say sometimes that the sum is more than the parts. I would say that at the price or the sum that this goes for, you get quite a few parts that would cost you more separately. Its Eurorack compatibility means that it can be used alongside semi-modular synths, helping out with its strengths such as the dual oscillators, its characterful filter, delay, and plenty of modulation sources. Finally, on the pros side, while I at first dismissed the preset cards as a gimmick, they are a quick way to get presets you're accustomed to going quickly and reduce cable clutter. Add to that the DIY potential, and PICO System 3 might be way more than it seems. It'll be interesting to see if a community of power feature cards develops around this. If you have ideas of what to put on these cards, for example, a light-sensitive photoresistor, please leave a comment below. For plenty of other ideas on what to do with all these envelopes, LFOs, and other modules, as well as much more, check out my ever-expanding book, now with a Eurorack for Beginners section available to people who support this channel on Patreon. Hit like if this was useful, and don't forget to ring the bell if you want to make sure you don't miss the next one. Thanks for watching.